Okay, so we're going to be talking about implicit derivatives, but when we take implicitly the second derivative. Okay, so um, let's start here. I need to find the second derivative implicitly in terms of x and y of this equation. Now it's a circle. Okay, so we start by taking the first derivative. So we always take the first derivative first. That's how it kind of works. So you get 2x plus 2y dy over dx equals 0. Okay, so that we know how to do. So derivative of x squared, 2x, derivative of y squared is 2y, dy over dx, because we took the derivative with something with y in it, and the derivative constant is 0. So now we solve for dy over dx. So we move the 2x over, divided by the 2y, so you get negative x over y. Okay, that's your first derivative. So before you can take the second derivative implicitly, you have to solve for dy over dx. You can't just start here and start taking the second derivative. Okay, so we get this as our first derivative. Now, we need to take the second derivative. So again, I'm going to take the derivative of both sides. So basically, I'm doing this. The derivative with respect to x again. Well, the derivative of dy over dx with respect to x, that is your second derivative with respect to x. Okay, but now we got to do that to the right side, and we have to do quotient rule. So low, which is y, times the derivative of high, which is negative 1, minus high times the derivative of low, and the derivative of y is dy over dx, all over the low squared. So we get that. So we'll simplify a little bit. So y times negative 1, that's negative y, negative, negative, positive, x dy over dx over y squared. So this is our second derivative, but there's one small problem. It says at the beginning to get our second derivative in terms of x and y, and here I have x, y, and I have a dy over dx. Well, I know what dy over dx is. This is dy over dx. So what we have to do is we have to then plug dy over dx into our second derivative to get it into terms of just x and y. So that's our last step. So we get negative y plus x times negative x over y squared. And we're going to finish simplifying. So we get x times x here. So that's x squared. So it'd be negative y minus x squared over y squared. Again, let's simplify this a little bit more. So we can split these up. So we get negative y over y squared minus x squared over y cubed, which gives us negative 1 over y minus x squared over y cubed, and that's our second derivative, d squared y over dx squared, written in its simplest terms. Okay. Now, technically, we could have stopped right here. Could have simplified, but we really don't want that fraction over a fraction. Okay. But that's the trick. So I don't want to say trick because that makes it sound like, ooh, it's a trick. But that's the caveat. With second derivatives, you're ending up with this dy over dx in it, and you can't leave it in terms of dy over dx. You can't have the second derivative in terms of a first derivative. So you actually have to come back here and plug your first derivative in to get it all in terms of x and y. Okay, so let's try this one. Same kind of thing. Okay, so the first thing you have to do is start with the first derivative. So we take the derivative with respect to x. And here we have product rule going on. So we're going to get 2xy plus x squared dy over dx minus 4 equals 0. Okay? Solve for my dy over dx. So when we do that, we get dy over dx. This goes over there, makes it positive. This goes over there, makes it negative. So you get 4 minus 2xy over x squared. So that's your first derivative. Okay? Again, our next step is to take this. Now that we have it in terms of dy over dx on one side, we take the second derivative, which gives us d squared y over dx squared. And of course we're doing quotient rule. So low, which is x squared, times the derivative high. Okay, now this is going to be crazy because derivative 4 is 0 minus, and then we got to take the derivative of 2xy. Now you could either put the minus with the 2x, or you could take it out and do product rule, but then you'd have to distribute it back in. So I'm just going to do it with the negative 2x being my first. So it's negative 2y minus 2x dy over dx minus 4 minus 2xy, which is the top, times the derivative of the bottom, which is 2x, all over x to the fourth. Okay, so let's do some simplifying. We get x squared times 0, which is 0, and x squared times 2y, which is negative 2x squared y, minus 2x cubed dy over dx, minus 2x times 4, which is 8x, negative, negative, positive, and that would be 4x squared y, all over x to the fourth. Now we got a lot more simplifying to do. Okay, but we're also going to have to plug in our dy over dx. Okay, so I'm going to do a couple steps at one time. I have this and this, which are basically the same terms. So I'm going to end up with positive 2x squared y minus 8x from here, minus this 2x cubed times my dy over dx, which is 4 minus 2xy over x squared, all over x to the fourth. Okay, so now we've got some simplifying to do. This makes it easy because this divides out with that, so we're left with 1 right there. So we multiply that to the top, so we get 2x squared y minus 8x minus 2x times 4, which is 8x, plus 2x times 2x, that's 4x squared y, all over x to the fourth. And then we just add up our new like terms. And we've got 4x squared y plus another 2. So that's 6x squared y minus 16x all over x to the fourth. And we could simplify it a little bit more, but that is basically in its best terms right there. And that's how you take second derivatives implicitly. Okay. Okay, the hardest part, and I'm going to move it out so you can kind of see all of it at the same time. Okay, if you look at all of this second problem, okay, this right here, calculus, taking the derivative, that was calculus. Getting from there to there, algebra. So that one step in our first derivative was calculus. The rest was all algebra. Same thing here. This right here, calculus. Going from the first derivative to the second derivative, that was the calculus part. After that, all the rest of this problem that we did, substituting the dy over dx, getting like terms, multiplying, that's all algebra. Okay? And that's what makes calculus sometimes difficult. It's not necessarily the calculus that's hard, it's the algebra and the adding like terms and missing a negative sign or positive sign. That kind of stuff is what's going to cause you to make mistakes. Okay? So when people tell me that calculus is hard, not really. It's not the calculus that most of my students struggle with. It's all this algebra that we did to get to here that causes them the most stress. Okay? So just be careful with your algebra.